This video is a revision on formal charge and how to calculate the formal charges. So for example, let's use something you've done in VSEPR, SO4, 2 minus. Okay, so formal charge, we count for each and every one of the atoms inside this ion. We take the number of the valence electron on each of them, and then we minus half of the number of bonding electrons for that certain atom, and then minus the number of non-bonding electrons. Okay, so let's do one for SO4 2 minus. We'll compare two ways of drawing it. So I'm gonna draw what we drew the other day. So we'll have a look at one structure that do not expand the octet of sulfur and one which expands the octet. Okay, sulfur has 6 outermost electrons. Then I'm going to fill in for the oxygen. And oxygen has 6 as well in the outermost. So this one do not expand the octet. So 1, 2 from sulfur, 1, 2, 3, 4, 5, 6 from oxygen, 1, 2, 3, 4, 5, 6 from oxygen, 1, 2, 3, 4, 5, 6, and 1 from the negative charge. 1, 2, 3, 4, 5, 6, and 1 more from the negative charge. Okay, let's do for the one that expand the octet. So we're going to form a double bond here. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. For the other two, oxygen. 1, 2, 3, 4, 5, 6, and 1 extra electron. 1, 2, 3, 4, 5, 6, and the extra electron. We're going to use this formula, number of valence electron minus half the number of bonding electrons, and then minus the number of non-bonding electrons. Let's do that. I put a star, a colored star, to mark each of the oxygens so that you know which one we're calculating. So sulfur, there's only one, and there's 2 types of oxygen here, one with the dative bond. So I put that in green star, and the one with the charge, a single bond here, that with a yellow star. Same goes for the one with expanded octet. The one with a double bond, I put in a green star, and the one with the single bond with the charge, yellow star. Okay, let's calculate for sulfur first. Sulfur has 6 outermost electrons. And let's count how many were bonded. So 1, 2, 3, 4, 5, 6, 7, 8. Half of that would be 4. And how many lone pairs or lone electrons? There's none. So the formal charge for this sulfur is 2+. Let's move on to the green star, oxygen. So outermost electrons for oxygen is also 6. Bonded electrons is 2, but half of that, so 1. And number of non-bonding electrons, that's 1, 2, 3, 4, 5, 6. So minus 1 minus. Okay, the other type of oxygen, so also 6 outermost electron minus half of the one that is bonding, which is also 1. And if we look at the non-bonding, it's also 6, so 1 minus as well. Let's try the expanded octet one. So sulfur here, 6 outermost electrons, 1, 2, 3, 4, 5, 6. So there's 12 bonding electrons, so half of that would be 6. And non-bonding, there's no non-bonding electrons around sulfur, so 0. Okay, the green star oxygen, 6 outermost electrons. Bonding electrons, that's 1, 2, 3, 4, so half of that is 2. And the non-bonding electrons, 1, 2, 3, 4. So that's 0. And the yellow star oxygen with a single bond here. So 6 outermost electron minus half of the bonding electron. That's 2 electrons that's bonding. So half of that will be 1. And non-bonding electrons, 1, 2, 3, 4, 5, 6. So 1 minus. So if you look here, in general, the preferred Lewis structure is the one which the formal charges are closest to 0. So actually the expanded octet is the preferred Lewis structure that we'll draw. So you do need to know both, but this is the preferred one because it's closer to 0, and this one has +2 and -1, -1. So it's not preferred. We can have a look at other examples here. So if we want to calculate for this oxygen that they point here with an arrow, so oxygen has 6 outermost electron, and the one that is bonding here is a single bond there, so 2 electrons, half of that would be 1. And minus the non-bonding electrons, that's 6, 1, 2, 3, 4, 5, 6. Therefore, we get 1 minus. Let's try this nitrogen here. So nitrogen has 5 outermost electrons. There's 8 bonding electrons here. 1, 2, 3, 4, 5, 6, 7, 8. So half of that is actually the number of bonds here. So there's 4. And minus the one that is not bonding, none of it is not bonding. So that's how we get 1 plus.